Assalamualaikum warahmatullahi wabarakatuh. Today we will present our lab 1, introduction of high voltage energy lab in Ftkee Utem. We will present about application of the kit 4.0 high voltage construction kit, which is the latest technology from Heafley Hipotronics in Switzerland. Our lecturer is CS Dr. Zikri Abadi bin Baharudin. First of all, we would like to introduce our group members. My name is Muhammad Ashraful Aiman. Second, Nurul Anis binti Ramli. And third, Nurul Shazwani binti Mazzuaini.
Okay, my name is Nurul Shazwani and I will present about the trace power cable circuit that is starting from the isolated switch 415 volt. Okay, this is the power input connection for the circuit. Firstly, there are 5 main cables of the equipment such as line 1, line 2, line 3, ground PE and neutral cable. The neutral cable is used if the input cable provides a neutral ground. The power cable is starting from isolated switch 415 volt to the power block terminal. Then it is distributed to the controlling circuit system and the transformer in the frequency converter. The internal transformer in the frequency converter is 0 volt to 440 volt. It is a variable instrument. It also have current transformer to reduce particular current. The 3-phase cable is connected to the input of the power block terminal. The output of the frequency converter has 2-phase cable and a grounding cable.
For the next tracing task is lamp and alarm circuit. Okay, so as we can see the schematic diagram, it is use module 821X2, which is there are 10 pins, which pin 7, 8, 9, 10 is connected. Pin 7 is common of the potential free contact, which is connected to the supplier 250 VAC and 6 ampere, while pin 8 is the switch potential free contact for the red lamp. Pin 9 is the switch potential free contact for the green lamp, and the pin 10 is the switch potential free contact for the alarm or horn. For the next slide, as we can see, there are 2 figures, which is there are 2 parts. In our lab, there are 2 parts of lamp and alarm system, which is one for the cell cache and another one for the frequency converter. The lamp and alarm system operate as an indicator for the kit whether the system is safe to use or not. It is the safety precaution to make sure that the kit is in a safe condition to operate. But somehow it will release interlock system, which is when the interlock is at normally closed, pin 9 will trigger and the green LED will turn on, while when the interlock is at normally open, pin 8 will trigger and the red LED will turn on. For the alarm which is connected to the pin 10 will trigger when there occur an injection voltage to the system.
I will present about the interlock system, which is connection from interlock system from the frequency converter to the sensor. This is the circuit of the interlock system. The whole circuit illustrates the interlock system and their connection to the control room. Interlock is used to monitor the door at the hatchway part of the system and to monitor if the ground rod is taken out from the high voltage. It can also be a door in safety fence mounted around the Heafley part. The interlock operates for dual channels function. Therefore, it tracks the time frame of discrepancy between the two contacts and also has a cross shot detector to avoid linking the two circuits in a fault case simultaneously. Okay, there is a sensor at the door called latching sensor to detect either the door is closed fully or not. If the door does not close properly, whenever to inject voltage or do testing, it will show the red alarm at the system, which is it cannot be done until the door are closed properly. Normally, interlock is for safety if anyone want to enter the control room while the operation want to start or in ongoing. There is the gap about 1 meter between the Heafley part and the control room. The gap is 1 meter because the Heafley part produce high corona. Shaded cables must be used for the interlock connection. Okay, this is the figure of the interlock at the FC cabinet, and this is latching sensor at the door. Next is emergency button. The circuit of the system and the connection to the control room. Okay, this is the circuit of the emergency stop button. Usually, there are two outputs for the emergency stop terminal, but we only use one in this specific case since we only had one cell. The whole circuit illustrates the emergency button system and their connection to the control room. The emergency stop operates for dual channel function. Therefore, it tracks the time frame of discrepancy between the two contacts and also has a cross shot detector to avoid linking the two circuits in a fault case simultaneously. The two output contactors and the input contacts of the kit cabinet are opened by pressing the emergency button. So there is no output voltage from the kit cabinet. Okay, for the example, when the instrument reach or exceed the threshold level, the instrument become hang or produce spark. The best choice to do is push the emergency button. Usually, the instrument already have their own threshold level, so that whenever it exceeds the limit, it will automatically active the grounding switch. The shielded cables must be used for emergency connection. If the second emergency stop is not used, the plug has to be bridged. The emergency stop has to be connected at least one. Okay, this is the figure of emergency stop at the FC cabinet, and the next one is emergency button in control room. Okay, that's all. I will pass it to my others team to present about the grounding system. Thank you.
Okay, next I will present about the trace grounding system. This is the ground switch connection for the equipment, and this is the ground connection at the test bay. Okay, the main grounding chamber from outside of the high voltage lab must be connected to the terminal outside of the lab. The chamber must have its own specific rod. It cannot mix with any kind of copper. From inside of the high voltage lab, copper braided is connected from grounding terminal block of the frequency converter to the high voltage transformer, or it is called a PZT transformer. The copper braided is used for grounding and earthing purpose. Okay, to make sure that the grounding line is function in a proper manner, the grounding for the lab must be very low potential. To avoid ground loops between different grounding points, the kit must be grounded at only one position to the ground rod. The resistance for the rod must be very low. It must be less than 2 ohms. Hence, the equipment must have its own grounding system. It cannot connect with the grounding for the building.
That's all from us. Thank you.